Hello and welcome to today's webinar on accelerating cloud services deployment with DDI automation. Thank you very much for spending the next 45 minutes or so with us. We appreciate your time. Please, as we go along here, we appreciate having any kind of questions or chat. There is a questions box that you'll see in the settings area. So we look forward to hearing from you. I'm Kirk Appelman. I am the General Manager and Vice President of EfficientIP for North America. I am joined today, or more appropriately, I am joining Bob Smiley. Bob is one of our Senior Solutions Architects, and he is out of Reno, Nevada. So today's for an agenda today. First off, I guess this is the welcome and introduction portion. We will then move on to talk about some of the challenges that cloud management brings to the table, and then talk a little bit about DDI being both an enabler for cloud deployments as well as opportunities for automation in deployment of cloud infrastructure. Then we'll show a demonstration on automation for cloud services, and then talk a little bit about a few takeaways. So first off, for those who are not familiar with EfficientIP, we are a network automation and security company focusing on DDI, that's DNS, DHCP, and IPAM. And our mission is to enable the dynamic, secure communication between the applications and those people who use the applications. We are the fastest growing DDI company on the planet, and we are in currently 110 countries. We are headquartered globally out of Paris, but have regional headquarters in Philadelphia for the North American market and in Singapore for Asia. So within those regional markets, we have all of the functions that interact with our customers and clients, not only sales and marketing and pre-sales, but also professional services, customer support, and finance and administrative functions. So everything as a client of EIP that you would interact with, you'd interact with our local regional headquarters. And today we support and count over 1,000 customers globally and over 250 customers here in North America, where several of these customers are represented on this slide. And many of these customers you see here have become very high profile over the last several months. Companies like, or organizations like Johns Hopkins, depend on EfficientIP DDI infrastructure to deliver on their mission for, well, their patients, their students, their community, and these days really the whole world. We also Netflix and Pfizer are also clients, and several of these clients actually have leveraged EfficientIP to enable their cloud deployment, and primarily in hybrid cloud environments. Organizations like Pfizer, like Bloomberg, deploying into the cloud, enabling cloud applications and automating that process was a key part of and a key priority of their projects where they implemented EfficientIP into their operations. And with that, I'll hand it over to Bob Smiley.
So thank you, Kirk. So the first thing that we're going to talk about are the challenges that we see with cloud management. Cloud adoption is a proven technology that's been a cornerstone for IT initiatives. You all understand that, and that's why you're on the call today. It allows for an almost unlimited availability of demand resources, but rather than putting all your eggs in a single digital basket, hybrid cloud offers the ability to decide which applications can be hosted in the public cloud and which ones can be kept in a private cloud environment. Nearly all of our customers have gone with the hybrid cloud approach, which is why we're focused on it. So hybrid cloud deployment management comes with a plethora of new headaches. You would assume that moving your assets from one infrastructure to another would be simple, but actually it's not. We still have all the management requirements that you had with your private data centers, plus a few new ones. Some of the things that we've been doing well for a long time on our local networks, such as inventory control, tracking, configuration, and automation take on a whole new perspective when running on a public cloud. And the key point here is that you rent resources in the cloud. You don't build a server and add applications to it. You build a server for the applications. And when you no longer need them, you tear that server down. And the reason for that is to control costs. Kind of like getting rid of all those annual subscriptions that you have on your phone that you're no longer using. There are multiple management solutions offered today, different public clouds with different management tools and user interfaces. Tools are deployed to make the automation quicker, such as Ansible, Terraform, etc., which may be homegrown or open source. But you can go the route to implement a commercially available cloud management platform as well. But what can happen is a clashing set of outcomes, such as multiple separate repositories with different resources under different platforms and different accounts siloed from each other, which could restrict the ability to automate, which is what we're talking about today. Okay, so to begin with, let's address the issues. Let's break it down into 3 challenge groups. The first group of challenges focus around visibility, consistency, and policies. I once had a conversation with the CIO who said they did not have public cloud resources. I told him I would be surprised by that and asked him how he knew, and recommended he check with the people who approve expenses, because I knew they had them, to see if anyone was making payments to a cloud service. He did, and they were. This is an example of shadow IT. It's hard to enforce IT policies, especially security, when you don't know what's there. The second group of challenges is around services becoming complex. Multi-tenant support can be challenging. And a third group of challenges is around security. We all know these were difficult to implement when everything was behind your firewalls. Hybrid cloud just exasperates the problems. So let's dive into the first challenges concerning visibility, consistency, and policies. IT managers generally have good visibility of IP resources in their own data center, but when VMs and IP resources are created in AWS or Azure, they can quickly lose sight of what's connected to the IP network, where it's located, importantly, why it is connected, so their asset inventory goes out of date. And it is a very dynamic environment if you're doing it correctly. This can lead to several issues, such as incomplete visibility of resources, policies not being enforced, service disruption due to configuration errors, and resources connecting to the network without authorization, posing potential security risks. The second set of challenges is around complexity of deploying and managing the resources. It's a very different thing to spin up a VM on a hypervisor in your local data center versus spinning one up in a public cloud. You'll see different terminology and language from one cloud vendor to the next. You may need to define regions, VPCs, security groups, record instance IDs, all these new cloud things. When you try and do it manually, it becomes very time consuming. There are so many things that need to be checked and verified, all the way from the networks and IP addresses to the adherence of corporate standards. The results can very well be that implementing a VM in the cloud can be much slower than implementing that VM in the DC, which is why a comprehensive DDI solution becomes a requirement. DDI solves the visibility, solves the control, and solves the automation headaches. Let's talk about how it accomplishes that, and in later sections, we're going to add the automation aspect to it. DDI is a network foundation for cloud infrastructure. DDI stands for DNS, DHCP, and IPAM. And IPAM is IP address management. DNS routes users to their applications. DHCP provides the IP addresses for devices to connect to the network. IPAM is the IP data repository and ensures a dynamic link between DNS and DHCP services to guarantee consistency and error-free connections. These are all tied into one cohesive system. For example, if I create an IPAM entry, it'll automatically create the DNS record. And just as important, if I delete the IPAM entry, it'll automatically delete the DNS record. That isn't just important for us humans, but it's important for APIs as well too. So it provides accessibility as far as finding where the applications are on the networks. It provides agility with the ability to automate your processes so that you can scale fast as far as building and decommissioning. And it helps you enforce policies just by the basic fact that you're able to see what's connected. IPAM is the central repository for seeing all your assets. It is much more than just a glorified spreadsheet. A good IPAM system should go out and discover what's on the network and report back to you what it sees. We've done a good job of tracking our internal resources in the past, polling routers and switches to find what they see, but it's even more important to know what you have rented in the cloud. And pings aren't always the best way to do that. Use an API from the IPAM to the cloud management system to get the best results. What you get from that is a single source of truth for your infrastructure. Even if the asset is in the cloud, it is still your resource. And even if you have multiple cloud deployments, you can easily find all your assets in one place, consolidating all the multiple repositories. It also makes sure your IP plan is consistent, which helps avoid conflicts. Data can be used for auditing and regulatory compliance, and as we will see, a good IPAM system is a requirement for automation. And last but not least, it ensures the integrity of your golden records. A good example of what a golden record is for EfficientIP is www.efficientip.com. It's as vital to our business as any other major asset. Without it, our business is impacted, so it needs to be protected. Confucius says, a man that has one watch knows exactly what time it is. A man who has two is never quite sure. I always say that, but it's not true. It's actually called Siegel's Law, but you get the point. The central repository.
I don't think they had watches in Confucius's time.
That's true. That's true. And I've been called out on that before. But the point is that if you have one single true source, then you know exactly what it is. If you have to go to multiple places to figure it out, you're never going to be quite sure. So the central repository lets network admins take back control and provide a unified management of the entire infrastructure. It gives them complete visibility of on-prem, private cloud, and public cloud resources from a single viewpoint. It helps admins with decisions related to new deployments or modifications, and it improves resource utilization and enforces company standards. It strengthens security, such as network managers now have better visibility of what resources are deployed or connected, and it mitigates shadow IT. The result is simplified, more efficient operations, so OpEx costs are reduced, and the time to deploy is vastly decreased. So hopefully I've done a good job of explaining why you need DDI. So let's look at the automation aspect and see why DDI is so critical to that piece of it. Lifecycle management is the process that defines how resources get implemented all the way through their retirement. I always like to reference a customer that did it really well, who sold tickets for touring artists. Willing to bet that you have been a customer of theirs. Before the tour would begin, they would spin up instances for information about the tours and the venue dates. They'd spin up instances to process payments and instances to provide updates to fans and all those unsolicited emails we love to get so much. When the tour was done, they would deprovision all the resources for that particular tour. They managed many multiple tours at once. By deprovisioning, they saved a tremendous amount of money and it helped grow an already profitable business. DDI is integral in the provisioning and deprovisioning process. When you provision, you pull data from IPAM. When you deprovision, you remove the data from IPAM. And the beauty of all that is that you still have one single source of truth. As we've already said, DDI is a network foundation for the cloud infrastructure, and it's used at multiple layers, especially for cloud implementations. At the bottom layer, the configuration layer, it tracks all the regions, VPCs, and their basic configurations. Then when configuring the networking and the networking policies, the orange layer, it tracks the networks and the assets on those networks. And at the orchestration layer, it provides individual machine information. It interacts with every cloud infrastructure layer. So it'd be a good idea to incorporate automated DDI in the orchestration process. And for that, and for fast, efficient rollout of services, an automated orchestrator agnostic DDI is essential. To accomplish that, the DDI and the orchestrator use APIs. So let's take a moment to talk about the APIs. Being in this business since before many of the people on this call were born, the APIs are not, all APIs are not equal, and we're not going to do a poll about if I've been in the business longer than the people have been alive. But the APIs are what enable a zero-touch configuration model. Imagine someday in the future asking Alexa to create networks and servers. It's not here today, but it won't surprise me when it happens. APIs are what make that possible. EfficientIP has baked APIs into the core product from the very first release. Every GUI call that we make invokes an API call to the operating system. And because of that, EfficientIP API is very robust and secure. And using APIs should not bring an IPAM system to its knees. I have customers here in the West that I know use more API calls to their IPAM system than people using the GUI. Also, we have a key customer that one of their biggest concerns was API error messages. This is so important to me because I never get things right the first time, and we have all probably had to look up a cryptic error message, especially for Microsoft, that had to do research and Google searches to figure out what it meant. So this customer wanted to make sure the orchestration team wasn't spending all their time asking the DDI team to help them figure out what the error would be. So the APIs make that single point of truth available to a wide ecosystem of partners. We've done previous webcasts where I talked about the APIs talking to the security ecosystem, and that same system can provide northbound and southbound calls to major orchestration systems. And as we discussed earlier, at multiple levels, at the network level, the host level, et cetera, et cetera. And API security is critical. Using API-based access control, you can not only limit what the API can do, but to what entities it can see and access. You can, and we absolutely recommend, to limit the span of visibility and control that your APIs have. We support multiple API standards such as Open API and REST and et cetera, so you can pick your method of access. So when we tie it all together, lifecycle management requires collaboration between multiple solutions. Automating this lifecycle management requires collaboration between different solutions, such as CMPs, an example of that's Morpheus, infrastructure as a code or infrastructure as a service, that would be Terraform, IT automation, a good example of that is Ansible, and continuous integration, an example of that is Jenkins. DDI is the cornerstone for all of these because they all have a common source of truth to derive the information that they need from. For this, DDI is the cornerstone. So it seems pretty obvious that DDI plays a vital role. Here's a quick recap of what DDI automation brings. First is a simple, fastest deployment of VMs and tenants and apps. Error-free configuration because you're not doing it from scratch every single time. That provides consistency and policy enforcement. It gives you a global visibility across all of your virtual environments. It has improved scalability, not only because you know what you have, but you know what's available to you, and a high availability of mission critical DNS and DHCP services. So now we're going to get into a demo, and I absolutely love it. And it was created by a couple of my colleagues. I want to give out a shout out to Nick Fannell and Alexander Chauvin. And I love this because what it's going to do is render a single image. And this is only a 1K image. We're not even going to do a 4K image. We're just doing a 1K. And the reason this rings true to me because a large group of my customers who were very early cloud adopters were the post-production facilities for a couple of Hollywood studios. Before the public clouds, they were huge data centers with rows and rows of servers and rows of storage, and made me a lot of money. But they didn't need all that hardware once they went to the public cloud. And the other thing was they had to schedule very precisely when they were working on different projects. So they went to the cloud and they tuned their processes so well that they would even check to see which cloud provider was the cheapest at that moment, cost per CPU, at the very instant that they would run the jobs. The set of servers would be created to process a single frame, and when that frame was completed, they'd deprovision all those servers, just like you're going to see today. So even today, even now, a feature film consists of about 158,400 frames, and we're just going to do just one. So the pieces that you need for this are the orchestrator, and we're going to use Terraform. You need the ray tracer or the render app, and in this case we're using Blender, And as far as the resources themselves, they're going to be running in AWS, which is going to be our cloud. Okay, first piece of it is the pieces that we're going to be using is first the Blender Grid Monitoring app. This is the app that's actually we're going to be watching, and it's the one that you see everything happen on. Second piece is going to be the grid, and the grid's going to reside in AWS. The third piece is the orchestrator, and we're using CMP, and we're using Terraform, and it's going to be our cloud management platform. And then last but not least is the efficient DDI solution. So it's going to consist of our IPAM, our manager, a device manager, and all the DNS that we're going to use to be able to pull this off. So phase one, we're going to build a network application environment. First, the orchestrator is going to go to the IPAM manager, and it's going to ask for the subnets that it's going to be allowed to use. The orchestrator is then going to provision the VPCs and the subnets, the route tables, and the internet gateway, all of the things that we know we need to make it work. Third thing that's going to happen then is that the orchestrator is going to go and create the DNS zone for the application. And the reason for that is so everything has the ability to talk to each other. Then we're going to add the grid manager. First, the orchestrator builds the grid manager and it's going to install the software for that. Next, the orchestrator then is going to come back to the IPAM and the device manager, and it's going to give the IP address and the name and the metadata that's associated with all of the devices it's creating. Next, the DDI system is going to create the DNS records in the application zones, right? This is why you tie your IPAM system together with the DNS system, so that when it's created an IPAM, the IPAM will automatically create the DNS records. The orchestrators don't have to go do those things. Next, the client application will then be able to resolve the master IP address, and we'll be ready to get started. And then the client can start communicating with the grid, with the master grid node. Each of these are going to be a step that we'll watch as the orchestrator builds them. Okay, once we start that, we have to build all of the servers that are actually going to be doing the work. So the orchestrator will build those VMs, and it's going to install all the software that it needs to work with the Blender app. Then DDI is informed that all of those have been created, and it's going to create the DNS records for those so that the apps will be able to go and find the individual servers. Next, the workers are going to get their jobs from the master and then do their part as far as putting together the image that the client is ready to pull when it's ready. And all of that is how you get the picture created. After you've admired it for a second, then what we're going to do is tear it down. To do that, first, the orchestrator is going to get rid of all the VMs and everything that's in the AWS infrastructure. Then the orchestrator is going to let DDI know that it let those go. After that, the IPAM manager is going to go and get rid of all of the DNS records that we created to make this happen. Okay, makes sense? Everybody understand what we're going to be doing? So then let's get started. This is the EfficientIP console, and this is the space that we're going to put things in. You can see we've already got a whole bunch of stuff in this, but if I do a search and a sort, what I'm going to do is find that I don't have anything running in AWS yet. So as far as the spaces go and the networks, nothing's populated in there yet. Next, we're going to go check Device Manager, and even inside of Device Manager, we have a ton of stuff there already, but what we're going to do is sort and filter again, and we're going to see that we don't have anything running in AWS at this time. And we have a zone, but there's nothing inside of it, right? Or we have the architecture to create the zone, but no zones have been created. So this is the Blender console. And you can tell down at the bottom that he can't find anything. Nothing's been created yet. So and all of that is because there's no DNS configured. So what we're going to do is we're going to start our first Terraform job, and it's going to go out and start building the initial pieces that we talked about. So we're going to be doing the manager and the master node. So you can see the process of it being created. And even this probably alone would have taken me longer than what we've done as far as the whole presentation. So we'll see now that we're starting to see things being created in IPAM. We see our first set of subnets created in the AWS space. We can find the name of the master and the IP address for it. We can go into DNS and we see that we have a zone for it now, and we have some records beginning to be created. Most of this created automatically when we created the zone, but we added the A record. We go into device manager, and now we can see that we have a device that we're going to be using as our master, along with additional metadata that we discovered as far as the AWS instance. So now we're going to create the first nodes that are going to go in and start doing the initial set of work for us. So you can tell that the job doesn't take too long. Again, even just this one point would have taken us much longer to do manually than this whole conversation. So we go back to our IPAM and are in our device manager, and we can see that it created 4 nodes. We go back into DNS and we can see that we've created additional DNS records for those, and that was done from the IPAM talking to DNS. And then we can go start to look at our networks and see that we're starting to add more devices, and we're starting to populate more things. We've discovered those, and again, they're in our IPAM database now. Okay, so we can see them being created. We have this on multiple networks because that's just the way life is all the time. You can't put everything on just one single network. You have to spread it across multiples. So the orchestration, automation, and the IP management piece helps you keep track of all of that stuff. Okay, so now our servers are starting. You can see the little squares, and it's going to take 97 jobs that you see in the queue to be able to render this image. And there's 3 servers that are being involved. And the time to complete, it hasn't even figured that out yet. So it's going to take it a little bit of time. It doesn't even know exactly how long yet. So I think to take care of that, what we should do is to start adding some more servers. And then what we'll do is start by running another orchestrator job. And then what that's going to do is add the other 12 servers just so we can get this done in a normal amount of time. So you can see them being created here. You can see the IP addresses that it created. You can see inside of AWS that we have all of our nodes, I think 17 of them all created correctly now, or being created. They're in the process of that. So the type of box that it is, again, some of the metadata that's associated with what these systems are. And then you'll be able to see when we refresh our IPAM that all of these were automatically added in. Okay, then we go to our networks and we can see that there's quite a few more devices there. And we can see that we have a lot more DNS records created. And in Device Manager, we're able to start seeing all of those there, including that metadata as far as what kind of device it was. So the monitoring system, it's starting to see the other ones pop up, right? You can see additional blue squares coming in, so the monitoring system's able to go and start seeing them. Now we're starting to get some times as far as jobs being done. The estimated time to completion right now is 20 minutes, but as each additional server comes up, you just start seeing that just absolutely fly by. So each one of the servers are now doing their piece of it. We're seeing the number of jobs in the queue absolutely drop. We're seeing the time being for completion going very, very quickly until we have this beautiful picture of Alex's favorite car here. So everything's completed and we've got our picture. We've admired it. So now, just as important as creating all of that, it's time to take it all down. Now, some people say it takes as long to, or as short to decommission as it does to commission it. I think actually it does take a little bit longer. It's a little bit more work. And that's why, as an industry, we've been very reluctant to do these kind of things. I see it all the time as far as stale DNS records, see it all the time as far as servers that have been sitting there not being decommissioned when they were done. So an orchestration system, an automation system does just as well decommissioning everything as it does doing the commissioning and the building of it. So again, this is really important in the cloud environment because you're renting these boxes. The longer that you have them up and running, the more money you're going to pay. So we can see that the orchestrator has terminated those jobs. Now all of those are shut down inside of AWS. They're not there anymore. Then we come back into the IPAM, and what I do is a refresh, and I see all of my resource records have been destroyed for that. Go back to my networks, and I can see that they're now gone, and that the number of IP addresses inside of those are now being gone. And I go back to my device manager, and I see that nothing's left there as well too. So again, as far as all of this goes, imagine if you would have had to do this by hand. If I would be the one doing it, I guarantee there would have been a ton of mistakes, and I would have spent a lot more time as far as double checking and triple checking myself just to make sure that I got things right.
Well, you're also just the world's worst typer, so I expect you to have a
Yeah.
lot more mistakes.
Well, that is why I am such an orchestration automation fan. That is absolutely the truth. Okay. So that's the main piece that we wanted to show you. Hopefully I tied it all together as far as the cloud is a different kind of environment that you still have to treat it as with as much care and detail and attention that you gave to your internal systems, that it's really important because we rent this stuff, we don't own it, and that we tie it all together, and that the IPAM piece plays a critical role in it. And without the IPAM piece, you can't do it. So the first thing is you can't control what you don't see. This is a fact of life. The same way that the sun comes up in the west and sets in the east. Oh wait, I got that one backwards again. It comes up in the east and sets in the west, but it's absolutely a fact of life that it does. And it's a fact of life that you can't control what you don't see. Second is that to be able to do this kind of orchestration and automation, you got to have a good IPAM system. You need that inventory. You need to know if it's been used and what's been used and where it's been used. Not only so much to know where you're at today, but to plan for what you're going to be doing next. After that, that IPAM and DDI brings a tremendous amount of time saving, and it guarantees error-free configurations, because as soon as you get that orchestrator working correctly the first time, you can use it over and over and over again. And the guys that hunt and peck on a keyboard like I do, you don't make mistakes anymore. Next is that you can still apply the same type of policies everywhere, right? Whether the resource is living in the cloud or whether it's living in your data center. And then what that means is once you have the repository, you're able to apply policies not just to the orchestration system itself, but to the security ecosystems that are part of it as well. And then last but not least, DDI is the key enabler for accelerating the rollout of the apps and services. If you don't have the DDI system in place first, what we just showed becomes impossible. Okay, and with that, any questions?
Thank you, Bob. And still, we're taking questions from anybody who's has any questions I'd like to forward to us. But I do have a few questions here that have come in through the course of the presentation, Bob. So let me hit you with a couple of these. So first off, from Sarah in Boise, what libraries are already written for the orchestrators?
That's a good question. We have quite a few. The place to go look as our source of truth, the one that we keep updated all the time, is GitLab. So you'll see that we have plenty of orchestrators or plenty of libraries written for different orchestrators there. If there's something that you don't see that you want, please let us know. The whole reason I wanted to ask poll questions during this is to learn what people use and how they use it, so I can learn from that as well too. So if there's something that you need, please let us know. GitLab is the place. Yep.
Fantastic. Okay, GitLab. So second question, do the API calls remain the same in different versions of Solid Server?
That's a good question too. And for the vast majority of them, the answer is yes. We strive very hard to make it so that any call that was in a previous release gets moved forward. Never an issue as far as staying in the same major release, but sometimes between major releases, we've had a burp or two, and we've been able to correct those very quickly.
Very good. Very good. Thank you very much. So Bob, any final comments, or those are the two questions that I chose to bring to the forefront?
I would like to say thank you for everybody for taking the time to listen to me today. But to me, this is a very critical and important piece of business, especially going forward. Automation and orchestration, again, we talked about how it makes it quicker, faster, and a less chance of making a mistake. So this is something that I think is not only important to me, but will become more and more important as the days, weeks, months, years, decades go by.
Fantastic. Thank you, Bob. And so for the audience, please reach out to us or any of your current EfficientIP contacts if you'd like to get into more detail about your specific requirements, your specific objectives. We look forward to continuing the conversation, and we have a lot more detail and expertise to bring to bear on your behalf. Again, thank you very much for attending today, and we look forward to speaking with you again soon on the next webinar.